Today we're going to be taking notes on solving multi-step equations. Now there's 5 main steps that we want to follow when we're solving multi-step equations. First step is distribute if necessary. Second step is combine all the like terms on the same sides. Third step is move the variables all to the same side. Fourth step is move constants to the same side. And then step 5 is solve for the variable. So when we're looking at this multi-step equation that we see up here, we can see that here's our equal sign, and we have a variable on both sides of the equation. And that's where these 5 steps really come into focus when we're trying to solve this. If we follow these 5 steps, we'll be able to get through this methodically. And that's what this is. Don't look at it and just say, oh no, I don't know what to do. This is really overwhelming. Go step by step. If you go step by step, then you shouldn't have too many problems. So the first step, it says distribute if necessary. Okay, I'm not going to worry about anything else on this equation. The only thing I'm going to do is distribute that 3 to the 2x and to the 1. So I have 6x plus 3 plus 2x equals 5x plus 12. Okay, I took care of step 1. Now, instead of worrying about everything else, all I'm going to do is move on to step 2. And step 2 says combine like terms on the same side. So I'm going to look at this side, and I have 6x and 2x. Those are my like terms. So that's what I want to combine on that side of the equal side. And now anytime I'm talking about side, I'm talking about sides of the equal sign. Over on the right-hand side, I have 5x plus 12. I don't have any like terms to combine on that side of the equal sign. So I'll say 8x plus 3 equals 5x plus 12. Step 2 is done. Now step 3 says move variables to the same side. So basically this is kind of like combining like terms. I'm not doing any division or anything like that. I just want to go ahead and move and get all of my variables onto one side of the equal sign, and that way I'll be able to solve it easier. And the way that I want to do that is I want to do the opposite of what it says. Now, this is an 8x, a positive 8x, and a positive 5x. So in order to solve this, I would have to subtract one or the other. The way I think about it is I like to have the coefficient in front of the variable to be positive. So that's just my thing. So what I like to do is I like to take away the lesser number so I know I'm going to have a positive coefficient. Most of the mistakes I make when I'm solving equations are dealing with negatives. I don't carry the negatives all the way down. And you'll find that's probably the majority of the mistakes you do. So I try to avoid having negative coefficients and negative terms as much as possible. And you can avoid that by going ahead and just looking at the problem and saying, well, if I took away 8x from both sides, I would have a negative 3x. But if I take away 5x from both sides, those guys cancel. 8 minus 5 is 3x plus 3, and all I'm left with is equals 12. Okay, so that's how we move our variables to the same side. I'm just adding and subtracting. I'm not doing any division. I'm not worried about that yet. I'm just basically moving it from one side to the other, just like we solve an equation. Now you can see I have a 2-step equation in front of me, and step 4 says move the constants to the same side. Constants are the numbers that are by themselves. So the 3 is my constant. So I'm going to subtract 3 from both sides. And I'm left with 3x equaling 9 Those guys canceled. And now it says just solve for the variable. So in order to do that, I'm going to divide both sides by 3, and x equals 3. Now we could go back and check ourselves, and we can say, okay, 3 times, let's see, 2 times 3 would be 6, 3 times, and 6 plus 1 is 7, so 3 times 7 is 21, plus 2 times 3, which is 6, and does that equal 5 times 3, which is 15, plus 12. Let's see, 21 plus 6 is 27, 15 plus 12 is 27, and so we have a check. So that's how we know that our answer is correct. Okay, so let's go ahead and practice one. What I'd like you to do is pause the video, go ahead and try and solve it on your own, and then go back and follow along with me and see if you got it right. Obviously, you want to use pencil, so if you did make any mistakes, you can go ahead and erase it. So here I have 4x. I'm distributing first step, plus 20. Got to distribute on this side as well. So it equals 6x plus 12. So the next thing I want to do is I want to get rid of my 4x. If you subtracted 6x from both sides, you most likely have the right answer. Okay, it's going to work out either way. It just is that you would be dividing by a -2, where I'm going to be dividing by a +2. So I subtract 4x. And I have 20 equals 2x plus 12. Now I'm going to move my 12 by subtracting that. Move my constants to the same side. I had no like terms, obviously, up above, so I went ahead and I skipped number 2. Then I have 8 equaling 2x, and 4, divide both sides by 4. I'm sorry, divide both sides by 2, and x equals 4. Now I want to go ahead and move on. We'll have some extra problems to practice with. But now I want to go ahead and move on to the back here. I'm sorry, the next section here. And I want to go ahead and talk about an identity and a null set. So first thing I want to do is, of course, I want to follow step 1, which is distribute if necessary, and obviously I do have to distribute. So 3 times y is 3y, minus 3 times 5, which is 15, or 3 times -5 is -15, plus 25 equals 3y plus 10. So the next step says combine any like terms. I have -15 and 25. So I have to say 3y plus 10 equals 3y plus 10. Hopefully you're seeing something here that's giving you a clue. So now our next step says move all the variables. So I'm going to subtract 3y from both sides. And if I do that, I end up with 10 equals 10. Whenever you have an answer like that, that's it. There's nothing else to be done. We call that an identity. There's nothing else to be done. An identity means that I can put any value in for y in this equation. Any single value for y that I want, I can substitute 2, I can substitute 2 million, I can substitute pi in for y. It doesn't matter what value I substitute in for y, it will always equal, both sides will equal the exact same thing. Now, the opposite of identity would be a null set. So let's go ahead and work this one out. The first step says to go ahead and distribute. So of course I'm going to distribute 2 to 2s and 2 to 3. But make sure, and if I hope that you've been watching, I'm bringing everything down line by line. So I'm going to rewrite negative 5s minus 14 equals 4s plus 6 minus 9s. The next thing that it says I need to do is combine any like terms, and I do have like terms. I have 4s and I have negative 9s. So I have negative 5s minus 14 equals negative 5s plus 6. So my next step says to move my variables to one side. So the opposite of minus 5s is plus 5s plus 5s. And once I do that, these guys cancel. And I have negative 14 equals 6. Well, we know that's not true. So we put a line through that, and we could either say null or put a line through a 0. That's another symbol for null. And we'll talk about other ways to identify identity sets or null sets in class. But what this is basically saying, it doesn't matter what value I put in for s, 0, 1, 16, a million, pi, it doesn't matter what I try to substitute in for the value of s, this side of the equation will never equal this side of the equation. Never. It'll never ever work. So what I'd like you to do, please, is I'd like you to go ahead and choose 2 problems that are in 1 through 9. Obviously, it's only the odd numbers, 1, 3, 5, 7, 9. So I want you to choose 2 problems from here. And below, for 11 through 19, for 11 through 19, I'd like you to choose 1, 2, 3, 4, 5. I'd like you to choose 3 problems down there. When you come into class, I'd like to be able to discuss these and talk about how to solve them. Thank you.